Okay, so now let us go through irrational numbers, and we're going to deal with this in how many steps? Just two only. So irrational numbers, to start with, what are irrational numbers? Irrational numbers are numbers which do not end. Yeah, so these are numbers which go on and on and on. For example, the square root of 2, it goes on and on when you punch it in the calculator. Also, the value of pi, you are going to get 3.1 yeah, so like the value of pi, it is 3.1419. It goes on and on, so it is an irrational number. So irrational numbers are numbers which do not end. You can say they are numbers which do not terminate, or numbers which cannot be expressed in the form of a over b. They cannot be expressed in form of a fraction. So now we're going to look at how we prove irrational numbers just within two steps. So these two steps I'm going to show you. Step 1, I call it the square step. How can we put it? Yeah, it is the square step. We're going to have something that will be our equation 1, and then equation 2, it will be the error step. That we're going to call it equation 2. Yeah, so just these two steps, the square step and the last step, which is the error step. Yeah, so all this will make sense. So now, before we even get started, I'll just like to explain like on this part. So there's a theorem in mathematics that if you have, like for example, like if you have, if we have a is equal to, let's say, 2x. So do you know what this means? It simply means that for such a number, that this coefficient which is in front, it means that it can go into a. It means it is divisible. Yeah, it means it is divisible. So like if we write a is equal to 3y, it means that 3 can go into a. That is the mathematics. And then now, the same theorem, it goes on to say if you have a squared is equal to 2x, it means that 2 can go into a squared, and a is just having a squared, meaning 2 can also go into a. So here let me explain it again nicely. So we're saying if we have anything like a is equal to 3y, if we have a squared is equal to 3y, this means that 3 is divisible by a squared. It means 3 can go into a squared without leaving a remainder. And then since 3 can go into a squared, it means even just a alone, it is divisible by 3. Yeah, so this is true if we have like a is equal to 4z. It means that 4 can go into a squared, and 4 can also go into a alone. Yeah, so that is just like our introductory part. Okay, so now let's get into it. A question will just say prove that the famous one is square root of 2. I think you have watched a lot of videos already, so let's pick something different. Prove that square root of 5 is an irrational number. So how do you prove that? So depending on your lecturer and the institution you are at, you can even be required to write a title. Yeah, they would score you a mark, but this is not so necessary. So we prove this by you can write a title. We write the title. You say proof by contradiction. So I've even remembered mathematical induction. So videos on mathematical inductions, you can check them out. So we prove irrational numbers by this proof by contradiction. This is where we're going to assume that a number is rational, and then we're going to prove it, whether it's truly rational or what. Okay, so let's get into it. So for us to prove that square root of 5 is irrational, so we prove that it is irrational. So how we prove? You just say let square root of 5 be equal to a over b. So this a over b, if you remember from the previous the last two videos under rational numbers, we said it means we're dealing with a rational number. So we want to check what will be the behavior. So remember, we only have two steps. Step 1, so this is just a summary of the things you will need to know. Step 1, we get equation 1 when we have a square root somewhere or a cube root, so I call it the square step. And then step 2, it is the error step. Yeah, so we're going to get this. So now what do we do next? So we're proving by contradiction. We now say we let square root of 5 is equal to a over b, and then from here let's get rid of the square root. It means we square both sides. So when we square both sides, we're going to have 5 is equal to a squared over b squared. And then at this point, let's make the numerator subject of the formula, meaning we just cross multiply. So we're going to have a squared is equal to 5b squared. Okay, so now at this point, you can see we have the power. We have the power 2. So this is our first step. We have done step 1. We're just remaining with step 2 and we're done. So, and then you have to write the following statement. You have to include it. So proof by contradiction, you just have to be writing statements like you're a robot. So at this point, do you know what it means? I was explaining. I said that if you have something like this, it means that this number, the coefficient which is in front, it means it is divisible by a. It means it can go into a without leaving a remainder. Yeah, and then since it can go into a squared, it means it can go into a squared. So since it can go into a squared, it means it can also go into a. So let's write this statement. So this statement is actually part of the solution. So you say therefore 5 is divisible. 5 is divisible by a squared because it is the coefficient like that. So 5 is divisible by a squared, which means that which means so Apanishwa answer in mathematics, which means that a is also a multiple of 5, is also divisible by 5, any of these. So this means that a is also a multiple of 5, since a squared is, so meaning also a. Yeah, so you are answering just like this. That's how we move. So 5 is divisible by a squared, meaning a is also divisible by 5. Therefore we can write a as a multiple of 5, like we just put any letter. So this is where I was calling it the error step. You have seen our step 2 has come out. So the first step, you just need to have a square. If it is power 3 sometimes, meaning you have a power 3, you get rid of it. And then next step will be the error step. So depending on the book, others will use another letter. So here, what it simply means that we're trying to say A can be divided by 5. So we have just put any letter so that 5 is the coefficient. Yeah, so we have these two things, equation 1 and equation 2. And then we just substitute. So we say substitute, I'll just say put equation 2 into equation 1. So you also write these same things. It will show that you understand. So where is equation 2? Let's write it. It's there. You can see it there. So equation 2 is a squared is equal to 5 over b squared. That was equation 1 rather. Yeah, so this equation 2 is going to be inside of equation 1. So this is our equation 1. You can remember it. It's just here, my 1, 2. Just here. So we have written equation 1. So now let's put equation 2 into equation 1. So meaning this equation 2, let's put it there. Irrational numbers are very irrational. So where there is a, we're going to substitute. So we have a square there. So where there is a, we'll put 5r like that. And then this will be equal to 5b squared. So we can simplify here. We have 25r squared is equal to 5b squared. Okay, and then from here we just simplify further. We say let's divide both sides by 5. So here divide by 5, also there divide by 5. So what we get is here when we divide we remain with 5 5r there. So this is 5r is equal to b squared. So again here we can write a statement. Do you know what it means? Like we have a b squared and we have a coefficient of 5 in front of a letter. So like this means that b squared is divisible, or you can say is a multiple. Yeah, so depending on your English. Yeah, so b squared is divisible by 5. Therefore b is also divisible by 5. Yeah, so if the big brother can eat 5, also the little brother can eat 5. That's what it means. So now this is a contradiction. So when you reach this point and then you just say therefore by proof by contradiction, you are just trying to say you have used proof by contradiction. So by proof by contradiction, the root 5 is irrational. So for me, the way I took this one, you just like master the steps, that's all. Root 5 is irrational. Why? Because a is a multiple of 5. A is a multiple of 5, and also b is a multiple of 5. We just saw this. A, it was a multiple of 5, and also b is a multiple of 5. B is a multiple of 5. Yeah, so what does this mean when A is a multiple of 5 and B is also a multiple of 5? This means that, yeah, so even write all this. This means that the fraction A over B was not in its simplest form. You finish. Yeah, this is how we deal with irrational numbers. You just master the steps like a computer. So now let me just run you through yet another example. So what other example can we give? The famous root 2. So prove that root 2 is irrational. This is how the question will always look. Prove that this is irrational. So we're going to prove by contradiction. So we say let 2, we say let square root of 2 is equal to A over B. So I think one thing which students don't understand here is that when we say square root of 2 is equal to A over B, what it means here, the reason why we do this is because we're trying to say that A is a multiple of a certain number and also B is a multiple of some other different number. The multiples should not be the same. That's what it means. So if you get the same multiples, then that number is irrational because it wasn't in its simplest form. That is the whole aim. So step 1, we just say let's get rid of the root. We get rid of it. We get rid of it. So we just cancel this and that. So we're going to have 2 is equal to A squared over B squared. And then from here, let's make the numerator subject. So we have A squared is equal to 2B squared. Remember, our 2 steps, we just have step 1, it is the square step. And then step 2, it is the error step. Yeah, and then now from here, so we have the squared now. So from here we just say let's move. So from here we just say okay. So this means that so some of the things I'm not writing. Yeah. So but just write as much as possible. So A squared is divisible. A squared is divisible by 2. The coefficient, therefore A also is divisible by 2. Yeah, if the big brother can eat chicken, also the little brother can. Oh, okay, so if A is divisible by 2, this means that we can write A as a multiple of 2. You just pick any letter. So we can pick like R. A is equal to 2R, simply meaning that A is a multiple of 2. Oh, okay. So when I get 2R, so remember this is equation 1 where you have the square. And then the next step is where you have the next step is where you have the R. So at this point you just say you substitute equation 2 into equation 1. So where is equation 2? It's that one on top which has a square. So you have A squared is equal to 2B squared. That was our equation 1. And then we substitute equation 2. Can you see equation 2? Yes, you can. So let me write it here. So A has a square there. Where there's A, we're putting 2r. Yeah, so I'll put in 2r where this here. So this is equal to 2b squared. So we can simplify this. We're going to have 4r squared. This will be equal to 2b squared. So to get rid of the, or to simplify, we just say over to both sides so that this can cancel. So what we remain with here, 4 divided by 2, it is just 2 r squared, and then here they cancel, we just have b squared. So do you know what this means? According to the theorem, you start writing therefore b squared is divisible or is a multiple, depending on how you be taught which word to use, is divisible by 2. Yeah, b squared is divisible by 2 because you can see 2 is the coefficient. If we happen to have 3, then we'll say it is divisible by 3. So if b squared is divisible by 2, then also b, it is divisible by 2. So at this point you can see, we said a is divisible by 2, also b is divisible by 2, then this is an irrational number because the fraction a over b was not written in its simplest form. Yeah, so from the first example I showed you, like you write the words. Some lecturers are so strict that they expect you to, you have to write that, and then you say you have proved by contradiction. Yeah, the conclusion should always come out. So this is all about irrational numbers. You just know the steps. Yeah, so you can be given anything. Let us do 2 more examples. Like you can be given proof that square root of 3 is an irrational number. You just say, oh, okay, square root of 3 is equal to a over b. Okay, so this means that if this were to be like rational, it wouldn't have the same multiples. But if we just end up with the same multiples, then it is an irrational number, meaning it never ends. That's what it means. Because okay, I shouldn't explain much. You don't have to understand the deep mathematics. So here we just say, okay, let's get rid of the square root. You just multiply by, you square both sides, meaning the negative, it will cancel. You know, negative and negative is positive, meaning we remain with 3. This cancels with this. Negative times negative is positive. So here we have a squared over b squared. Yeah, and then you make a squared the subject. You have 3b squared. Do you know what this means? It means that a squared is a multiple. A squared is a multiple of 3 here. Therefore, a is also a multiple of 3. So as soon as you see the square both sides, then that is equation 1. And then you just go on with the same steps. So since a is a multiple of 3, then we can write a is equal to r. Guess what number will be in front? We're going to put 3. Yeah, so let's rewrite equation 1. So meaning as soon as you see the r, this is equation 2. So if we rewrite equation 1, we have a squared is equal to 3b squared. So now let's put equation 2 into equation 1. So where there's a, we just put brackets and the square. So this is equal to 3b squared. So a is 3r. So let's simplify. 3 times 3, 9. R times r, r squared. 3b squared. And then to simplify, we divide by 3, divide by 3. Here we remain with 3r squared. There we remain with just b. Therefore, b squared is a multiple of 3 here. Since b squared is a multiple of 3, then b is also a multiple of 3. You write. Therefore, we said a is a multiple of 3 and also b is a multiple of 3. Therefore, negative root 3 is an irrational number because a over b are both multiples of 3. Hence, they were not, the fraction was not in its simplest form. So this is just how you go about it. I think solving more examples will just be exhausted. Yeah, so this is the approach, except for this one last one. So it will not always be easy. They can ask you something you're not familiar with. They can give you, okay, root 10, given that, yeah, so this is a question which is even in the document. So given that root 10 is irrational, they've given you this condition, okay. Wait, oh no, they don't give it like this. I always remember that question. This question usually comes a lot at Copperbelt University. Wait, how does it come? Let me just look at the document. Okay, so behold the Megaminds document. So this is example 4. There are more examples on top there. Some very nice things. Yeah, I've even answered this. Yeah, so ensure you go through the document. I've answered more questions there. So our next thing will be looking at set intervals and the number line. So what if they give you that square root of 10 is an irrational number? They've given you leakage that, okay, square root of 10 is irrational. Can you prove that when you add square root of 2 and square root of 5, you're also going to get an irrational? Yeah, so this would be like 3 marks. Yeah, so let's quickly do this one and we stop. So actually, gosh, I didn't forget. Yeah, so it's just like this. If they give you that square root of 10 is irrational, they even give you that, oh, this one is irrational. Can you prove that when you add square root of 2 plus square root of 5, this would be irrational? There are some questions like this and even other questions in different forms. So how do you approach this? So you basically go with what you have to deal with. So they have just told us that square root of 10 is irrational, but they want us to prove that when we add these two, it is somehow irrational. Okay, so what do? We say root 2 plus root 5. Let us assume that this is equal to a over b, just like we have been doing. Oh, okay, and then what next? Let us try to get rid of the roots. So meaning we square, and even here we square. So here you now have to start multiplying. So this simply means that you have like root 2 plus root 5 times root 2 plus root 5. Yeah, so we start multiplying root 2 times root 2, this times that. So I'm going to show you this shortcut. We're going to learn it even in the other topic, which is SADS. We're going to do it SADS. So, but quickly, how do you multiply here? You just say, what is root 2 times root 2? Yeah, so I'll not explain much. Just know that it is 2. When you do SADS, you are going to understand. Yeah, okay. We can just do it anyway. Root 2 times root 2. It simply means you multiply what's inside. This is 4. 2 times 2, 4. Square root of 2. Square root of 4, you know it's 2. Yeah, so root 2 times root 2, you get 2 here. That's the whole thing. And then plus root 2 times root 5. You just multiply what's inside. Root 2 times root 5, 2 times 5 it's 10. And then since we have 2 items, we multiply by 2 outside. It's just 2. Yeah, so I feel like just pausing this, we're going to do it when we do SADs, but let's just answer. So this is what you get, and then root 5 times root 5, it is just 5. So this is equal to a squared over b squared. So here it can be complicating. Just open the brackets, you start multiplying one by one. In here there's 5. Root 2 times root 2, this times that, this times this other one, this times that, that times that, you're going to end up with this. So we're going to do this again in SADs. Yeah, so and then from here you just continue simplifying. Oh, we have some unfinished business. Okay, so from here what do you do next? You can just simplify. We have 2 and then from here we just add. Yeah, so 2 plus 5, we know it is 7. So we have 2 root 10 plus 2 plus 5 there, it is 7. So this is equal to a squared over b squared. And then from here we collect like terms. We have yeah, so we just want to take this to the other side. We have 2 root 10 on this side is equal to a squared over b squared minus 7. Yeah, and then from here, oh, still have unfinished business here. And then from here we can just make this as a single fraction. So we say square root of 10 is equal to, so here meaning we have over 1. So common denominator b squared, a squared minus 7b squared. So how to make a single fraction? Just b squared times 1 b squared, 1 times a squared, b squared times 7 7b squared. Yeah, and then from here we can also get rid of the 2 here. We can say, okay, let's divide by 2. We divide by 2 both sides. So we'll end up with square root of 10 is equal to a squared minus 7b squared over b squared. So this is divide by, so 2 is over 1. So if we change it to multiplication, it's going to be 1 over 2. Yeah, so this question, and then from here, this is root 10 is equal to a squared minus 7b squared. So here, when you are solving, you are just trying to see where it will take you. So it has reached us to this point. So remember in the question, it was given that root 10 is an irrational number. And then what we did, we just added root 2 plus root 5. And then we are trying to see what will happen when we say it is equal to a over b. So what we've ended up with here, we've ended up with the left hand side, it is root 10, and root 10, they already told us that it's irrational. Root 10 is irrational. Okay, and then what about the right hand side? On the right hand side we have a fraction. On the right hand side we have a fraction which is a over b. So on the left hand side you can see that we have an irrational number which is root 10. But on the right hand side we have a fraction. Remember, a fraction is rational. So therefore this is a contradiction because the left hand side is not equal to the right hand side. So like Therefore, you conclude, therefore root 2, when you add it with root 5, it's not is not, oh, you just say is irrational. Is irrational. Yeah, and then why is it irrational? It's because left hand side is not equal to right hand side, because irrational is not equal to rational. Yeah, so this was it. Just basically all about knowing the steps. You just know the steps. Yeah, so remember key things. Step 1, you are going to have a square, like the normal questions which come. Step 1, you have a square, and then step 2, you have to ensure that now you have R somewhere. Yeah, so practice more, continue practicing more, and yeah. So at the end of the video, have you understood how to show that root 2 is irrational? If you've understood, you can subscribe and then check out for more videos which will be posted.